Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concept of reaction rates. So what is a reaction rate? Well, basically we're looking at the time it takes for a reaction to go to completion, for the reactants to become products. And when we're looking at these things, what happens is we study how fast these reactions occur. And typically reactants will be consumed in a reaction while products are produced. It takes a collision between the reactants at the right angle, right velocity, or kinetic energy to become a product. We need to be able to convert that collision energy, kinetic energy, into a vibrational energy strong enough to break the bonds of the reactants and form the bonds of the products. So, in other words, it has to be an effective collision. There, according to the collision theory, a few things that aid in increasing the number of effective collisions. If we have a higher concentration of the reactants, then this aids in the number of effective collisions, which makes sense. The more of them there are, the more likely two of them are going to collide with the right conditions. Higher temperature. If you remember, temperature is a measure of average kinetic energy. So if the temperature increases, the kinetic energy increases, velocity increases, and the amount of vibrational energy will also be very large, making the odds higher for the bonds to be broken of the reactants and formed of the products. If we have the reactants divided or more finely broken down, thereby exposing a larger surface area, then we will have more effective collisions. And that's about it. So make sure they have the right velocity, orientation, and all of these things will lead to an effective collision. Now, this vibrational energy barrier, or this energy that we have to overcome, is referred to as activation energy. And if we're looking at a potential energy diagram, as we have here, where potential energy is the y-axis and time or reaction progress is the x-axis, then we have this type of scenario occurring in which this line from the reactants to that peak, which is the transition state, indicated by this line with a double dagger through it, okay, and transition state is a state that's partly between the reactants and partly products. So it's somewhere in between. Some bonds are being broken, others are being formed. And the difference in potential energy between the transition state, which is the highest peak always, and the reactants is activation energy. That's the barrier it must overcome to get to the products. Whereas the difference between the reactants and the products, that's the enthalpy. Okay? Now in this scenario, we have reactants which are greater than products in their energy. So energy was given off. So that's basically it with the introduction to reaction rates. We're going to look at them as conceptually in part 2 as a decrease of reactants versus an increase of products. And then we will look at reaction rates derived experimentally and overall reaction rate order. So make sure you check out all those videos and their corresponding example videos. I hope I've eliminated any doubts you might have. Thank you and have a nice day.